to exist, the difference between science and engineering projects. So let's talk about what should you do. Okay, so why do a science fair project? There are a couple benefits. The first one is you get to learn more about science or engineering. And if you're interested in any of that stuff, and you're thinking that in the future you may want to study that in college, it's a good way to get started early or still in junior high or high school. It's also a way to figure out whether you like the area enough to major in college as well. So that's the first benefit. But I would say an even bigger benefit is really developing the skills that is needed to solve problems. So critical thinking skills, the ability to do independent learning, because that's a skill that you'll be using in college. And I can tell you that I still use it every day at work. As well as time management skills, project management skills, and communication skills. Again, it's the kind of skills that I'm using every day at work. Right? And how I built it was since high school when I worked on my science fair project. Now, of course, if you do well, then you may win some prizes. I call those nice souvenirs. And there may be, in some cases, scholarships involved. For ISEF, the top prize is, if I remember correctly, $75,000. It's a nice chunk of change. And of course, it also prepare you for college, but more importantly, career. Okay. Literally for myself, my science fair project was the foundation, was the starting point of my career that's lasted several decades. Now, I just talked about why you may want to do science fair, science research. Why might you not want to do it? Okay, let's also talk about that as well. Number one, that it is very time involved. Okay, let's be very open about it. Typically, that if you really want to do a good project, you're talking about multiple months of effort, or in many cases of the students I know that really do well, that they do this year round, or in some cases the project lasts for multiple years. So it's a pretty big time commitment. When my son did science fair back in 9th grade, he did both science fair and science Olympiad at the same time. And as he got into as he was getting to 10th grade, we saw that his workload was increasing, and I basically told him that pick one. You cannot do both. Right? So he ended up picking science fair and stopped doing science Olympiad. Okay? You have to pick and choose. It's a very time-consuming thing, especially if you want to put in the effort and do well in it. Second thing is that if you're interested in STEM, that nowadays there are many different types of STEM activities. There's science Olympiad, there are the various robotics competition, there are programming contests, and so on. And all those competitions, they have different kind of pros and cons and different styles. And if you're really into robotics, for example, and you like to work with a team of people, that robotics may be pretty attractive. So science fair is not the only route. Now, science fair is different in the sense that it requires students to really work and think independently. So it is actually, I would say, in a sense, the closest kind of training that they would get compared to what they would be doing in college and the real world. So in that sense, it's very good preparation. That in my own case, literally, myself and my son went through this sort of training, and we credit that for launching our careers. But at the same time, it does put more demand on students. So another things that you want to consider, and also ask the parents in this room to work with your child to consider, is whether you think your child is ready for it, whether you think the person has the maturity to do it, has the time to do it, and so on. Because you want to find the right kind of activity where the students can do well and excel in and not get overly frustrated. Okay, because if that happens, they may lose the interest, and that's not good. Okay, so do consider that. science research-based competition. Because the goal is that hopefully by the end of this talk, number one, that you know what this is about more, and then number two, that you consider doing it, right? So that's the point of this presentation. And to start off, we do have to answer a question of, okay, we're talking about research-based competition. So what is research? Okay, let's think about that. So I'm borrowing this picture from Dr. Matt White, who is a professor at University of Utah, and he teaches computer science. So he has this article called The Illustrated Guide to Getting a PhD. Okay, so I'm borrowing his idea. And in this picture, imagine this circle is a depiction of the body of human knowledge. So all the things about human knowledge is contained in this circle. Next slide. To learn about things. So of the entire body knowledge, you start learning something about math or English or science or social science and so on. Next. And when you go to high school, you learn more. Next. When you go into college, you learn even more, and then chances are you'll be majoring in something, so you're specializing in one area. Next slide. And when you go further beyond college, let's say you go into graduate school, you learn even more. You go into professional world, you learn even more, and eventually you get to, you're really getting specialized, and you're getting to sort of the edge of knowledge for a given area. Next slide. Let's blow it up. So that looks like this. Okay, you're really at the edge of knowledge for a given area. All right, next slide. And then you discover something new. Okay, you discover something new. You actually push beyond the edge of human knowledge. The activity involved in doing this, in general, is research. This is research. Research is about building human knowledge. It's about discovery. It's about learning something new. It's pretty neat, right? Next slide. So that's research. Then what is a science fair? Fundamentally, science fair is a competition in which you get to bring your discovery and share to the world and compete for prizes. In essence, that's what it is. Okay, and you can do projects in many different areas. In fact, across all areas of science or engineering. Includes everything in biological science, physical science, different disciplines of engineering, computer science, and so on. And these are just examples from the categories of Alameda County Science Engineering Fair a couple of years ago. Okay, so these are just some examples of the categories of projects that you can work on. Next slide. All right, so let's be a bit more concrete. These are examples of a couple of different projects that actually competed in the fair. So first one, right, develop and save an easy UVC device for face mask sterilization and reuse. And that was during the time of COVID. So this project was about making face masks clean and sterile. Right. Next one, soil. This is a silver seasoning project, right, to figure out ways that we can protect our levees so that when there's a flood, that will be protected. Combining plant-based materials to clean polluted water. This is an environmental science project. Effect of changing wind speed, mass, and friction on accumulation of embers during wildfire. This one is serious. So this one is about studying the behavior of amber. So when there's a wildfire, to see how they progress, and we can predict how wildfire can spread, and we can, through that knowledge, right, protect ourselves. And last but not least, the effect of reading sheet music on visual working memory. This is a behavioral science project, right? Learning about if you study music, right? How might that benefit your working memory? Right? So these are just some examples of projects that students in Alameda County have worked on. Next slide. Speaking of Alameda County, that if you're interested in participating in science fair programs, this is typically your starting point, the local county science fair. And in Alameda County, we have the Alameda County Science and Engineering Fair, typically held in March. And then from that fair, the best project would proceed on to the next phase, which would be either the California Science and Engineering Fair, or for the very top projects of the fair at both. So for junior high and high school, they can go to California Science and Engineering Fair. For the top high school projects, they can go to International Science and Engineering Fair. And then for the top junior high projects, they can go to the Thermo Fisher Scientific Junior Innovator Challenge, formerly known as the Broadcom Challenge. So this is how the science fair system is set up. You start at the local level and then proceed to the state or international or national level. Now, I don't know if all of you are from Fremont or Alameda County, but let me just point out, just to be complete, that each of the county in the Bay Area has its own science. Let's talk about why you should or do not do the fair and what it is. Let's go into a little bit of the mechanics, okay? Because one of the biggest challenges for working on research-based competition or work on science fair project is coming up with project idea. And that is oftentimes, you're getting started is the toughest step. Okay, so I'll provide some tips, some insights on how you may be able to do that. There are a couple of different ways of doing it. First way is if you happen to run into a problem that you want to solve, or you want to run into something that you're curious about, right? That could be a source of project idea. And in fact, that's how I got started with my project. Back in my junior year, I was learning a programming language called COBOL. Okay, COBOL. Okay, and the weird thing was I learned that after I learned Pascal, after I took AP Computer Science. And it was so frustrating that I decided to write a Pascal program to help me write COBOL code. And that turned into the beginning of my science fair project. That's how I got started. Right? And so I was actually, the reason why I had a project ready to go was because I was working on something to solve my own problems, and it turns out that it was good enough to be a science fair project. My son happened to, his second science fair project was also something similar. He was making music video for his swim team, and he got rather frustrated about choosing the music to express the mood. So he ended up working on some AI stuff in order to build a music search engine, right, to make it easy to find the right music. So his project was also based on the problems that he cared to solve. But there are more than one way of finding ideas. Looking around the world, right, at problems that are out there, current events is another way. Reading about things from science magazines, from journals. One thing that graduate students do a lot, the ones doing PhD, what they do a lot when they start out is they have to do about readings. That's what those programs put the students through, and that's how you get, oftentimes, to get the research ideas. Another way to get idea is look at what other students have done in the past. Now, that is not to say you want to copy the idea. Please do not do that, okay? But the way that science and engineering is done is ideas are oftentimes built on another ideas. We don't just create things out of nowhere in vacuum. So by looking at what other students have done, that you may be able to find an idea to do something that may be along that general concept, but explore something that project did not look at before. So that would be a legitimate way to use a student research from previously in order to jumpstart your idea. And then lastly, that there are many websites out there, science website. One of them is called Science Buddies. And they have a lot of project ideas, okay? But I would caution you of using those verbatim, because those ideas are so common that there are a lot of students doing it, oftentimes for class projects. So what you want to do with those websites, or those ideas from those websites, is use that as a reference, and then generate your own idea by changing what they show on the website. And I'll show an example of that next one. Pick up the newspaper, read about it, okay? This is one way you can get research ideas. Okay? There are all kinds of problems in the world that are waiting for people to solve. And during COVID time, we saw many projects that were related to figuring out how to use face masks, effectiveness of face masks, and so on and so on. Right? Definitely very timely kind of subject. And you can just similarly look around right now and see what kind of problems are out there. And you may get some ideas of what kind of problems you want to solve. Next slide. Science magazine. Okay, so these are just some general science magazines. Or if you want to go deeper, some research journals. Okay, that's another source of information. And by reading more, you get more ideas. Next slide. Previous student projects, how do you find them? Well, as it turns out, that the California Science and Engineering Fair has a database of previous student projects. Now, they have a lot of those informations between the late 90s and the 2000s, all the way to about 2020. Since they moved to an online or hybrid kind of format, that they use a different systems. So it seems like, I looked at the other day, that they haven't updated this site for the last couple of years, but still there's a lot of older projects in there, and it's still pretty good source of information. Next slide. So if I go there. International Science Engineering Fair also has a project database. So if you just search ISAF project database, that you will be able to get to the website and look at the projects that students have done before. And that database is very up to date. Okay, so I talk about science buddies. So let me give you an example of how you can use a website like this to generate your own project idea. So in this case, that on Science Buddies, that there is a project for breaking what is known as a Caesar cipher. Okay, a cipher is it's a piece of software that is used to encrypt or protect information, and Caesar cipher is a very simplistic or overly simplistic way of doing it. Essentially, it just works by changing the characters around. Okay, so on the Science Buddy website, it will list such a project, and the time requires only for 2 to 5 days. Obviously, a very simple project. So once you get the idea, what do you do with it? Well, I mean, you may want to play around with it, just try. But what you want to do is pick this idea and see how you can modify it in order to come up with your original concept. Next slide. And then here's more background information, okay? And in this case, that when you read the background, it will tell you that, well, Caesar cipher is very insecure. You can crack it easily, and here's how you can crack it. And one key method is what is known as frequency analysis. Frequency analysis, what is that? So you want to read about that. Next slide. And, well, let's go to the internet and do a bit of research. So let's find out what sort of research has been done, right, to defeat the frequency analysis attack. Okay, and as you go on the internet, go on Google and search, and sure enough, that a bunch of interesting websites comes back. And the first one that came off the list is from Purdue Computer Science Department. So when you go to do search like that, it will start bringing in relevant information, and you can learn more and more. Next slide. And then you go, okay, so maybe you want to ask the questions of, okay, what are the challenges of designing ciphers? Okay, and then you get to read more about this. Okay, next slide. And in that, in what we just read, there was something about lightweight block cipher. Okay, so lightweight block cipher. Can that be used for different use cases? So for example, that we tend to think about computer as a laptop or or our phone and so on. But what about IoT devices, say the security cameras or the smart locks and so on? We need to protect those things. Okay, maybe it makes sense to have a cipher that can run in those devices that have limited hardware. Has anyone tried that idea? Let's do a search on that. Lightweight lock cipher for IoT. Okay. Next one. And we'll see that, it turns out that there have been some research done on it. Okay, so found about 1,400 papers on lightweight cryptography in the last 10 years, according to Google Scholar, and something showed up in workshop. And this is how you can take a subject that's very simplistic in science studies and really get to more details and change it, right, in order to come up with your own research idea. That's more brief. Next one. One other thing I want to point out is how you can find background information. A very good way of doing it, thanks to Google, is Google Scholar. So you can go on and search for any topic, and that would return you a bunch of work, research that has been done before, and it's a great way to learn about background information. Next one. Another way you can do this is just on regular Google search. If you type any search string, and then you type in the parameter site, :edu, then space, file type, PDF. Actually, next two slides. PDF, then you'll be searching for only articles, a PDF file, published at .edu, which typically are universities. That's another trick, right? Another way you can pull research. Now let me tell you, it is so wonderful these days we have search engines. Because back in my days, when I had to do background research, it means showing up to the library, okay, and looking up stacks and stacks of research, or stacks and stacks of journals, taking them off the shelf and going to the photocopy machine and paying 5 cents per page to copy them. So we are in a wonderful world today that you can actually just go on Google, and then within minutes you can get back a lot of background information that you can use to learn about things. Next slide. So Google, next slide. Another thing you can do is when you get one paper, it turns out that you can use that paper to learn about what are the other related papers, because they typically would have references to related material. So if you're able to find the first research paper, and then you go to the reference section, you can find a lot of other related information. So that's another trick to do background research. Next one. Okay, so I just shared with you what's research, what's science fair, different kind of science fair, why you should do it, why you should not do it, and some ideas to get started. Now let's talk about a couple of the mechanical things. And one of them is deadlines. So the thing about research is, in a way, in the real world, when you do research, that there may not necessarily be a deadline. You can work on it for as long as you wish, well, at least maybe before you die or something, or you run out of money. But for science fair, there is a deadline because science fair takes place at a certain time. And for ASAP, typically it's held in March of every year. So next one is going to be March of 2025. And the reason why they hold it in March is because California State Science Fair typically takes place in April. And then ISAP typically takes place in May. So in order for them to select people in this fair, they have to make sure that they hold a fair before those two others. And now, before you do a project, okay, you have to submit your ideas to the Alameda County Science and Engineering Fair organization so that they can review your idea. There's a reason for that, and I'll show you in an upcoming slide. And then, of course, you want to get a project done before the fair. And I would say do not target March to be your completion date, okay? Let's build in a bit of cushion and get it done by February. Okay, that way, sometimes, in case something goes wrong, and invariably things oftentimes, sudden events, unexpected things that can happen when you do research. That way, you can still finish your project before the actual start of the day. Next slide. Covered by the Bay Area Science Fair. Okay, so, but all in all, that all these fairs start at the local county level. Next slide, please. Now, besides the local county science fair, which feed into the state and international fairs, there are also two very notable research-based competitions. And one of them is the Science Talent Search. This is only for high school seniors and is known as the High School Nobel Prize. Very, very prestigious program. And so in that program, students would submit their research and they pick the top 300 projects in the country as semi-finalists. And then out of that, they select the top 40 to bring to Washington, D.C. for the final interview. And then select the final winners. Another one is the Junior Science and Humanities Symposium. And this is more of a science conference for high school students. And students compete to submit paper in order to present at the event. Next slide. Now, I just talked about, okay, what is the science fair? And so we know that there's local, international, national level, and so on. But what kind of projects can you do besides that there are different subjects? It turns out that there are two styles of projects that students can do at a science and engineering fair. After all, it's called science and engineering fair for a reason. So you can either do a science project or you can do an engineering project. What's the difference? Okay. Well, the difference lies in what is science versus engineering. In a science, or in science research, what you are looking to do is to learn about a natural phenomenon and be able to explain it. So for example, that hundreds of years ago, Isaac Newton, from what we heard, was under an apple tree, right? And then the apple fell down and was wondering, how come apple would fall to the ground? That's the question, right? And he did research and eventually figured out that, it's because of gravity, right? And then from that, we got Newton, the first, second law of physics, and so on. That's science, okay? It's about figuring out how to explain some sort of phenomenon. Now, engineering is different. Engineering typically is taking certain knowledge and then make use of it. But we're talking about engineering research here, okay? So in this case, it is to figuring out how to apply certain knowledge and then test whether something can be built. So for example, that, let's say we don't know whether we can take off, build an aircraft that can take off vertically, right? So let's try it, let's try that out. Implement an aircraft that can take off vertically within a confined space and carry at least 11 passengers for over 300 miles. Now notice that it's pretty specific, right? This is engineering, because when you are doing engineering work, you have to specify, well, what are the goals that you're trying to achieve? In this case, not only does an aircraft, we want to test the visibility of an aircraft taking vertically, but it has to be able to carry at least 11 passengers and be able to fly at least 300 miles, right? So that's the nature of engineering research, is you have to define the parameters that you're trying to test the design against. Next slide, please.
So, Ari, can you move on to the next slide? So what is MIT INVENTOR? MIT INVENTOR is an open source platform backed by 10 years of research from the best researchers at Google and MIT. This platform is mainly dedicated to supporting students across the world to be able to create apps. And usually, for people doing coding, what you'll be doing, like get started with, will probably be JavaScript, right? Me personally, I got started with coding with React.js, which I did professional website development for 2 years. But to get into React.js or how to do full stack development, it takes a very long time for you to get used to the environment and be familiar with the technology. And in order to create a simple app, which you have to be able to do really fast if you're doing research projects, you will need to do something called rapid prototyping. In this case, you might use something similar to MIT INVENTOR, which obviously I would recommend. But if you want to make something else, you can also use Flutter, right? Well, okay. Can you move on to next? So it's one, because a lot of I'm pretty sure a lot of high schoolers here, if you guys are taking CS, you've probably heard of APCSP. On a final project, you're supposed to create an app. And actually, you can use an MIT App Vendor to create your final project for APCSA. I mean APCSP, rather. And also, MIT App Vendor is 80% similar and transferable to Java. So it allows students who are taking APCSA as well to be able to get familiar with the Java logic. So currently, it has 18 million users across the world with 100 million apps being built with 200 countries and regions that it impacts. And actually 48% of those regions that it impacts are developing world. So right now, I just want to show this is the app. Oh, can you mention? Okay. Can you move on to the next? All right. So I don't have my. I guess the video is not going to play, but I did a research project this year on polyphonic music generation with MCRN. In this project, okay, once you do the research, you'll be like, okay, so I created this AI model, a multi-dimensional recurrent neural network, hundreds and thousands of the street set vectors. No, that is very hard for the judges to visualize. What you want to do is to visualize with a product. For here, my project is to my target audience is musicians and composers, right? So I will have to create an app that creates the music. So this way, the judges can really see oh, I can listen to the song that it's generated. Right? Instead of just looking at a bunch of street set vectors and an MP3 file. Right? So that's why apps is so important for research to help you visualize your project and really prototype it. Right? So you have a use case, which is something that's very important. Because in ICEP and these competitions, one of the major factors that judges will evaluate and take in is its impact. What is it? It's social impact, right? So some of the benefits of MIT App Inventor is that it's very simple to use. For a beginner to get started into MIT App Vendor, you can probably make your first app within 1 hour. I'm not joking. You can pretty much make a very simple app because you do not need to do any front-end development. You can literally just drag the elements, even though it might not look that good. However, it's working. It's working demo, right? And then, as I said, it's very fast, very simple to use. For AI integration, all you have to do is literally just drag the API block and enter the API link. Or if you're coding your own model, like here, you can just export your project as an API and then put that API link. And also, this thing is completely free and available to anyone, so anyone can use it. So yeah. AI research, which right now is probably really popular, regardless of what field you're doing. You could be doing biomedical or chemistry. AI is going to be something that's going to be incorporated into all fields, same with apps. So therefore, I believe that learning AI and app development is going to be a key skill for anyone of any field to really know and just have. So that's why I really want to encourage everyone here to just search up MIT App Vendor, check out the website, try it out. But try to create a simple app. There's a bunch of tutorials online on his website, on YouTube channel. Or you can just go join our Discord server. We have a bunch of demo apps in our Discord server. Right. And then one more thing, for Apping Club, I saw there was a question on resources. How can you become more, involved in AI research? What you can do is participate in activities and events like this, right? So in Apping Club today, we had the in-person AI research lecture. But in July, we'll have our Innovator Summer Camp. And then also we'll have our UI design course. And at the end of August, we'll have our data analysis workshop. Throughout the summer, one of our major initiatives is one, expanding chapter clubs. So if anyone here, if you guys have not heard of an Apping chapter club in a school, you can become your own local leader, apply to become a chapter club leader. And then our officer application 3.0 is also open right now for the third time. And then in November, our main focus is going to be the Apping Research Competition, which before that we're going to have a lot of paving. The events listed over here are the confirmed events. We're trying to plan a lot of other events. For example, one of our Apping Club members, Andrew Liang, is the first place winner for behavioral science in the ISEF finals. And four of our, and also we had like a bunch of ISEF finalists from Apping Club. So we're thinking about inviting those members to give a lecture on their experience in creating their projects. Also, one more thing I just want to mention, another great way to learn is to really go and participate in summits and conferences. AI conferences, for example, one that just happened before was the Gen AI Summit. You guys can check it out. Gen AI Summit, San Francisco 2024. It was an amazing summit with top AI leaders and startup leaders. And in those experiences, students can really be engaged in the real world AI projects and what the startups are doing. And in fact, in this summer, in July, MIT Rise is hosting the AI and Education Summit. It's co-hosted by the INVENTOR Foundation. And in this event, if you guys want, hey, the registration is still open, so feel free to check it out and maybe participate. Can you scroll down a little bit? And also one more thing, aside from ISEF competitions, a lot of conferences, they will host something called a call for poster and call for paper. Like Chung said, ISEF is a premier level for high school research competition. It is very hard to be able to be selected as a finalist. In fact, even winning at the regional level is very difficult. However, conferences, there's a lot of them. So guess what? If they have a call for paper, why not submit? Right? Like Chung said, signs up of courage, right? What is the fear to submit to a conference like this, right? You can submit. This one, unfortunately, the deadline's already over, but in future conferences, you can just search it up on like Open Review. You'll find a bunch of conferences. So in those like sites, you'll be able to find the conferences and just like find one and maybe you can submit. So yeah, maybe we'll go back to this slide here. I believe the last slide is just the advertisement, right? Okay, yeah, never mind. But in general, that's basically all I wanted to say about MIT INVENTOR and AI. I hope everyone here can, really be benefited by this lecture and event. And I'm very thankful and honored to have Chom over here to give an amazing lecture on research, ISEF, and the journey. So yeah, that's all from my side. And if you guys have any questions, Chom can answer. Yes.